Okay, this is a video for 7.3G rotations. Let's do problem number 8 because it'll let us do a whole bunch of rotations, and you can see kind of how things play out as you rotate points and rotate entire triangles, and you'll see how they rotate at 90 degrees, 180 degrees, and 270 degrees. So the first thing the instructions says graph the following triangles. We'll have to graph the original and then the 3 rotations as well. There'll be 4 triangles on the graph. The original are the 3 points underlined in black. So 2, 5 is right here, 0, 5 is right here, and 1, 3 is right here. There's our original triangle. Now, we want to rotate that triangle 90 degrees, 180 degrees, and 270 degrees. There's a couple ways we can do this. First, I like to start with the 180 degrees. I know the 180 degrees, that rotation, brings it halfway around the graph. And so, to get halfway around the graph, everything is just opposite. When you had positive numbers, we now have negative numbers. If you had negative numbers, you now have positive numbers. So instead of 2, 5, we'll now have negative 2, negative 5. Instead of 0, 5, we'll still have 0, but then we'll have negative 5. And instead of 1, 3, we'll have negative 1, negative 3. So let's graph these points. Negative 2, negative 5 is right here. 0, negative 5 is right here. And negative 1, negative 3 is right here. And now we have rotated our figure 180 degrees clockwise. Now let's do 90 degrees. You can see that our original figure is in quadrant 1. You can see that our 180 degree rotation is in quadrant 3. A 90 degree rotation clockwise is going to go this way, and so we can assume that our figure is going to end up in quadrant 4. Now, sometimes this can be hard to visualize. If it is hard to visualize, you can always use the table that's listed in your note packet. That table looks something like this. A 90 degree rotation clockwise is going to take the points x, y and map them to y, negative x. What that means is your original points, x, y, are going to go to y, negative x. So your new point, your new x value is going to be exactly the same as what your y value was, and your new y value is going to be the opposite of what your x value was. So let's take a look. For our first point, 2, 5. If we want to rotate it 90 degrees, our new x value has to be what our y value was. So our y value was 5, so now our x value is 5. And then our new y value has to be the opposite of what our x value is. So that must be negative 2. For the second point, 0, 5, our new x value needs to be what our old y value was, so that's 5 again. And our new y value needs to be the opposite of our old x value, which the opposite of 0 is still 0. And finally, for 1, 3, our new x value needs to be what our old y value was, which is 3. And our new y value needs to be the opposite of our old x value, which will be negative 1. Now, we need to plot those 3 points. 5, negative 2 is right here. 5, 0 is right here on the x-axis. And 3, negative 1 is right here. Connect those dots. There's our triangle. All right, finally, for a 270 degree rotation, If you can visualize it, that's great. We know it's going to end up in quadrant 2. And a 270-degree rotation from our table in our note packet looks like this. Take your original x and y value and it maps it to the opposite of y, comma, x. So what that means is our new x value is going to be the opposite of what our old y value was. In this case, our old y value was 5, so our new x value is -5. And our new y value is going to be the same as what our x value was. Our x value was 2, so our new y value is 2. For 0, 5, our new x value will be the opposite of our old y value. That'll be -5 again. And our new y value will be the same as our old x value, which is 0. Finally, for 1, 3, that'll give us -3 and 1. Now we need to plot these 3 points. -5, 2 is right here, -5, 0 is right here, and -3, 1 is right there. Connect the dots for our triangle, and now we have, now we have plotted all 4 triangles. We've rotated the first original triangle 90 degrees, which is the red, 180 degrees, which is the blue, and 270 degrees, which is the green.